Now let's take a look at the interpretation of the second derivative. We need to compare the signs of both the first derivative and the second derivative to determine if the function itself is increasing or decreasing, and if that change is slowing down or speeding up. So there's two things that can occur. The first and second derivative could have the same sign. And again, we're looking at f prime and f double prime. If that happens, then that means that the changes, let's say any increase or decrease in f prime, is occurring at an increasing rate. So let's take a look at a couple of examples. What if our first derivative is greater than 0? That means it's positive. And also our second derivative is greater than 0 or positive. Well, if the first derivative is positive, that means that f of x is increasing and that it's increasing at a faster rate. So imagine we have a graph that's going upwards like this. Notice it is concave up. So if we were to look at the slope of the first derivative, that slope as we go along is getting steeper and steeper and steeper. In other words, higher and higher and higher. So it's increasing faster. So we can say f of x is increasing at an increasing rate. The fact that we know that f of x is increasing is the fact that f prime is positive, and that it's doing so at an increasing rate is because f prime and f double prime have the same sign. Well, it's also possible for both the first derivative and the second derivative to be less than 0. In other words, for both to be negative. That means the function is decreasing, but also decreasing quickly. Think of it like jumping off a cliff. Your distance to the ground is going to be decreasing, but it's going to be decreasing quickly. So we can say that f of x is decreasing at an increasing rate. So again, we know f of x is decreasing because f prime is negative, but we know it's doing so at an increasing rate because the first derivative and the second derivative have the same sign. Now let's look at what happens when your first and second derivative have opposite signs. That means that the changes will occur at a decreasing rate. So suppose that your first derivative is positive, greater than 0, but your second derivative is negative or less than 0. Since f prime is positive, that means it's increasing, but as it increases, that increase starts to slow down. So we can say that f of x is increasing at a decreasing rate. Again, we know f of x is increasing because f prime is positive, and we know it's at a decreasing rate because the first derivative and the second derivative have different signs. Then what if our first derivative is less than 0 or negative, and our second derivative is greater than 0 or positive? First derivative being negative tells us that our function is decreasing, but it's decreasing at a slower rate. You're not jumping off a cliff. So we can say f of x is decreasing at a decreasing rate. See if you can tell why we know f of x is decreasing and why we know it's decreasing at a decreasing rate. So in example B, we're just going to kind of tie all of this in together by just looking at the signs. So let's interpret if the first derivative is positive and the second derivative at x equals a is also positive. That means that f of x is increasing at the point x equals a at an increasing rate. For 2, if the first derivative is negative and the second derivative is also negative, that means that f of x is decreasing at x equals a at an increasing rate. In part 3, our first derivative is positive, but our second derivative is negative. So that first part tells us that f of x is increasing at x equals a, but the fact that the signs are different tells us that it's doing so at a decreasing rate. Now the very last one, you can pause and see if you could do it on your own. Otherwise, our first derivative is less than 0, so it's negative, and our second derivative is greater than 0, so it's positive. This tells us that f of x is decreasing at x equals a at a decreasing rate. Now let's take a look at the last example. The number of births to women 35 to 39 years old in the U.S. was modeled by the function b of t equals 208.6 times t to the 1/4, where t is between 1 and 14 with the endpoints included, and where t is the number of years since 1984, and b is the number of births in thousands. So let's pay attention to the fact that t equals 0 represents the year 1984, and b is going to be in thousands. So they're asking us in part 1 to evaluate and interpret b of 10. So let's plug in 10 into our function, and we get approximately 370.949. So we have found out the number of births in thousands, and remember 10 is our t. So if t equals 10, that would be 1984 plus 10 years. So we're looking at 1994. So to interpret this, we would say, in 1994, the number of births to women 35 to 39 years old in the U.S. was 370,949 births. So remember, the in thousands for b means that we take the value for b and multiply it by 1,000 for our interpretation. For part 2, it asks us to evaluate and interpret b prime of 10. So we would first need to find the first derivative of our function. So don't forget to multiply the front by the exponent and then subtract 1, and then we'll get 52.15 t to the negative 3/4. Now we can plug in our 10, and we get 9.274. That is still a b value with respect to x, so we still multiply it by 1,000 for our interpretation. So we would say, in 1994, the number of births to women 35 to 39 years old in the U.S. was increasing by 9,274 births per year. That is our first derivative. Now let's scroll down to part 3, where they want us to evaluate and interpret the second derivative at 10. So we would take this function, which is the first derivative, and take the derivative again. And we would get a negative 39.1125 t to the negative 7/4. Now let's plug in our 10. And we get approximately a negative 0.6955. And remember, when we go to interpret, we would multiply this by 1,000. Now that's going to be approximately 695.5. So we might want to round up to 69.6 depending on how they want us to interpret it, but they didn't specify here. So we can interpret this as, in 1994, the number of births to women 35 to 39 years old in the U.S. was increasing at a decreasing rate of 696 births per year per year. In other words, they were still increasing, but it wasn't increasing as quickly.